Thank you very much, and welcome to the technology and innovation session. In this session, we're gonna talk about what's hot in new technology, and how we can capitalize that onto all the global industry and also on the businesses. So today we want to actually discuss two major topics in which you may be interested in. What are the game changers? What are the frontiers? What are the hindering issues? It could be the 3D printing or robotics or big data, IoT, AI, or biotech medical devices. Although we're not going to talk about biotech medical devices today, but what are the game changers? Or are these good list, or do we have something else? What are the unexpected the problem with those? And then how to explore them. But the global trend in the hardware startup, of course, we know a lot about the internet startups, but now we have more and more hardware startups, coming. And what is the new network-centric hardware startup global trend? And of course, this is Japanese audience, pretty much majority is what is strategy for Japan to get into this and to be one of the major player. Okay, now, so I would like to turn the microphone to the panelists, and then each panelist gonna talk about their position for 5 minutes or so, and then we're gonna move into the discussion afterwards. Okay. So first, Benjamin gonna share with us his account. What?
All right. Thanks for your kind introduction, and a pleasure to be here today. So my job at Hacks is to work with startups and invest and support startups across the entire spectrum of hardware. So basically what we try to do is to combine the best resources for entrepreneurs, wherever they're from, so that they can build global companies. So we work with startups from around the world. We bring them to Shenzhen, China, so that they can engage with the supply chain over there. And then at the end of the program that lasts about 4 months, we take them to Silicon Valley so that they can present their innovation to the world. So we take startups typically at very early stage, at a prototype stage, sometimes kind of research type, and then we try to take them as fast as possible to market. Myself, I've been working in Asia for about 15 years. I worked in Japan. でももう10年も経ってますんで。なんか日本語はもうなんかこの全部のプレゼンテーションはまだありえないと思います。残念ながら。So sadly, I cannot present everything into Japanese because it's been a bit too long. But in the meantime, I worked in Korea, in Singapore, in Silicon Valley, and in China. And I feel it's a very, very special time to be working in China, not just any place, but in Shenzhen, because it has basically the best place to make electronics in the world at scale, and even for early stage. Quick overview of what we do. So we invest in startups from around the world. It happens so that about 60% of them come from North America, US and Canada, about 20% from US, and 20% across Asia. So far we invested in 80 startups. Only one from Japan. We keep trying to find a good match for our investment model. And about 10% from China. So the founders come from many famous places like those. I just wanted to give you a few examples of startups we invested in, because it's not the typical thing you might hear about in mass media. So the categories we cover are like robotics, IoT, advanced manufacturing, health and lifestyle. But if we look more specifically, it's actually not those type. So it's not activity trackers, it's not smartwatches, and it's not humanoid robots, even though I love Atom, right? I think those are already kind of done on the market. And on the one on the left and the one on the right, the humanoid robot, is kind of the old view of the future from basically Tezuka Osamu. So it's been, we need to update this vision, and the future is already there, but we don't necessarily see it very well because it's very subtle. I'll give you some examples of robotics companies we invested in. So the one on the left is an autonomous cleaning robot for commercial spaces. So if you try to put a Roomba in a supermarket, it's going to take a whole week probably to clean. Because it's not very smart, it's not very big, and it's not very fast. Normally people use this type of machines to clean large places. But with advances in robotics and lower cost of sensors, you can now create autonomous machines that can actually scan an entire place, decide the right path, and then execute on it. The one in the middle is a biotech robot that helps lab techs to do pipetting. Pipetting, you take one liquid from one place to another. It's a big time waste in laboratories, and it's not very high added value. So this automates it. And there are machines on the market to do this, but typically they cost $100,000. This one is less than $5,000. It's an example of a big change going for robotics to go from the mainframe era, very large, very big, not scalable, complex, expensive, to the desktop or workshop era. The one on the right is a very low-cost robotic arm that basically has a lot of degrees of freedom, inverse kinematics. For those in robotics, you kind of understand what that means. And it's very useful for many applications that are much more flexible than what you could do with factory-type robots that are great for very specialized things. And this is also less than $5,000. A few IoT tools, those are I'd say, the foundation of getting more products ready. And prototyping faster helps to have more innovation at lower cost and get faster to market. The one on the left allows prototyping of circuit boards, and the one in the middle is for connectivity, for Wi-Fi, Bluetooth, cellular connectivity at very low cost. And the one on the right is actually the world's first $9 computer. And I'll give a few more details about that. So a full computer for $9. You can browse the internet, you can check your email, you can watch YouTube with this little chip on the right that's about a quarter the size of a banana. Advanced manufacturing, I just have one example here. It's actually, I think we mentioned just earlier, fabric tissue printing. Well, this actually comes from the biotech world, and it doesn't print human tissue, but it prints fabric from scratch, basically from a liquid polymer, liquid polyester, or even silk, liquid silk. You can create fabric, and you can create custom, seamless garments. And there's a good chance that this will bring like a revolution in the garment industry and maybe in a lot of technical fabrics. Another one in the health, a few examples in the health sector. The one on the left is a smart insole with about 100 pressure sensors inside the insole that allows very precise pressure mapping of your feet. So the first application is for medical, for diabetic patients who lose sensation in their feet and are at risk of amputation. But anyone who's doing any type of sport who sees that generally is quite interested. Like even people playing golf, they're like, I would like to know how my feet are doing when I'm playing because I could improve my game. And people doing running and all sorts of other sports also really interested. So it's going to expand from medical to mainstream applications. The one in the middle is a portable blood testing device. Basically, you could have that at home, and every month or every week or after every meal, you could test your blood and have precise markers and test for not only if you have active problem conditions, but also preconditions. So many of us might be pre-diabetics, but we don't even know it because we won't test until we have a real issue that appears. The one on the right I mentioned briefly is actually a sedentary, like you could say the world's first inactivity tracker. Because most of the time, such as today, we're sitting, and we know it's not very good for our health, and we know we're sitting too long, but we don't know really what to do, and how much we should stand, how active we should be. Some people go the other extreme and get a standing desk or walking desk, but probably being standing all day long is also not very healthy. So this can help you. To conclude, a few lifestyle products, connected lights, Polaroid device for smartphones. And the one on the right is actually an interesting collaboration with Onkyo. It's the first headphones to help you sleep. So those guys have decided to focus on the light sleepers, the business travelers, the people who have a lot of problems sleeping and need to sleep for performing in their job or their daily life. And it's a totally different type of criteria that people have been thinking about for headphones. Mostly people talk about audio quality and design. And this one is for sleeping. And their competition is actually not really headphones. Their competition is sleeping pills. It's a more natural way. And obviously, because it's headphones, they still needed a high-quality audio. And because they are more medical engineers and mechanical engineers, they partnered with Onkyo to cover the audio part. So it's a very interesting product, and this one raised close to $2 million on Kickstarter, and is going to retail soon. So I mentioned here like a few that did really well on crowdfunding. So we use a Kickstarter over 30 times with our startups. And it's a great way to get market feedback, early sales, find some partners, find some investment. It's been very beneficial. So just to mention, to conclude on with the one on the right, what happens when you get a computer for $9? What happens in the world? So I think we're moving gradually through an evolution from just expecting things to be only connected to the internet to things actually measuring things, and eventually to objects being intelligent. Intelligence means having autonomy and having the ability to react and perform on their own. So it's basically putting computers into things and apps, running apps onto things. So in a sense, if you compare to like the early stages of life on Earth, those are really, really simple creatures. And that's what we have today mostly. Just connectivity and one, two, or few senses. But the future is to really have this Cambrian explosion of devices, because making something intelligent, putting a computer in it, is $10. And maybe it will be even less. So even a humble toaster could actually have maybe face recognition, so that when you walk in the kitchen, it recognizes you and knows the type of toast you like, and then turn itself off if you leave the kitchen, because it has also presence sensor. And the smart toaster would maybe be $10, $20 more than the dumb one. So we'll come to expect things to be smart and reactive instead of us doing all the work. So I think that's a really interesting future we're heading to. So I'm not sure exactly what the shape of the next Apple will be. Since I'm in China, a lot of the times, Xiaomi, you probably heard, as a giant smartphone and connected device company from China that just grew out of nothing 5 years ago and now is worth $50 billion. I think there's really like an ocean of opportunities, and I look forward to see what Japan can do on that. Thank you.
Wow, pretty interesting. Thank you very much, Benjamin. Pretty interesting portfolio of investment that you made. And okay, next, I think we're going to move to,
Thank you.
Okay, so Kawada-san, can you, share with us your experience on this next stage? And yeah.
Is it gonna work?
I think you're gonna, yeah.
Oh, good. That's by the way, it's Mongolia. It's a beautiful country. I don't know why.
You have to actually get the full screen, otherwise it's not gonna be
Yeah. Okay. You saw a little bit about my robot at the beginning. 2 arms, eyes, working. So I show you why we're doing it. Here's the economic growth of Japan. And it was great, about 5% GDP growth every year till about 1990, and it went down, and since then it's been really tough, even for my company also. And now we have Abenomics, and it's coming up, and it's been good, but with the recent situation, including my stock, it's gone down, so it's very uncertain. But one of the Abenomics, very fortunate for me, is Mr. Abe says the third arrow. One of the third arrows is the robotics revolution, robot industrial revolution. So these are some of the ideas about the robots applications. Many different applications. Agricultural, medical, etc. But my company is concentrating on Japanese manufacturing. Japan has been always very good with making things, and I was always been very fond of Sony products. Unfortunately, I only see Apple products here, but I'd like to see Sony come back again, although Sony's not my customer. So what did the manufacturing look like before? Manufacturing factory look like before? Look like that. Can you see everybody? Can everyone see it? People lined up. working hard. I don't know where that is. Maybe Detroit. I don't know. And this was ridiculed by Charlie Chaplin. Working very hard, like people, workers are slave to machines. Correct. So this is what the 20th century manufacturing was like. So what does it look like now? Looks exactly the same, just a different race of people working, but it looks exactly the same. This is why many of the manufacturing disappear from America. Don't look at the one in the middle. Disappear from America, even from Japan this past 10 years. This is how we lost our manufacturing. And now, this is another way. This is Detroit in 1920s or 30s or 40s or whatever. And what does it look like now? It look like this. Okay, factories kept in the country, nobody working. Robots are working, and that's quite sad. There's a new type of robots that are emerging now. They are called collaborative robot. And these are the examples from one on the left is American, a Baxter. One on the right, I think a Danish company or a Dutch company called Universal Robotics. KUKA on the left bottom, and ABB at the bottom. These are collaborative robots. See how happy they look working with the robot? They didn't lose their jobs to robot. So that's what this new type of robot I am betting on is.
I'm going to briefly talking about the kind of different way of a similar thing. My name is Jun Rai. My background is a computer network, but anyway, computer science. And my name is Jun, Jun, Japan University Network. So I'm talking about the university. I'm talking about the university as well. Let me see. Okay. So the internet is basically connecting everybody in the world already. So it's we have images at least that every single person on this planet are utilizing, connecting, participating on the internet. Meaning that participation, meaning that the individual is important. Individual brain, individual sense, individual experiences are going to be digitized and to be shared. Okay, so that's a really important part from now on. Okay, so each of you is going to be the node of the internet, right? And so that's a point of my thought. And then also the device and the sensors and small computers, as described already, $9. But these are Intel, so a little bit more expensive. But now the IoT means used to be the Internet of Things, but starting from the RFID concept, but now it's a full computer in each of the things, and therefore the full stack of computers and the full browsers and the full web protocols and everything. And then a lot of data generated from all those sensors, cameras, everything. Therefore, we need a very, very strong processing powers for the data anyway. So that might be hidden into the cloud system, but that's a fact. So this is what it is like today, or in 5 years or whatever. So it's almost there. So. We already talked about the 3D printer things. I'm sorry. This is my university, a library. So we have a lot of digital fabricator things open for the students, so the student can do anything with the sewing machines and everything connecting to the internet. Therefore, all the data shared among them is a design. In the 3D design thing. So that's, then the students created this, and probably I want to notice that this is a download this thing, not download this music, right? So click, and you can print, meaning that you can download the thing, okay? So this is different. So one of our students created this, and then 3 lines at a time. So I don't know what it means. 3 times performance about writing anything. But anyway, so as soon as this was up, then in all over the world, they did the same thing. But the important thing is that this is a design, 3D design things. Therefore, you can modify things. So this is a kind of social network of the design. Therefore, one of the musicians created the 5-pencil version of this, so that it can apply to the music. And so this is one of the example of the personalized thing. Wait a minute. So look at this. This is the artificial leg was used. This is today what it is. A lot of factories and a lot of parts to have an artificial leg for the replacing the leg. So then it's a lot of work, and then the experts was needed. But today, that can be done by 3D printer. Okay, so with a nice design and a beautiful leg as an existing one, and the scanning from the existing leg, and then print by the software. Therefore, you don't need the experts and the factories in a local locations. So our students created the system, and then the soft materials that Kitano-san mentioned was used. And then, a lot of, the 3D printer function in the software can be exporting to anywhere in the world, so that the artificial leg can be produced in anywhere. So this is a Philippines, and then our students are moving the entire system to the local areas and the rural areas, and then where a lot of people are, demand is very high. And then this beautiful girl, the leg, and then with that can be created locally by local materials. So this is more toward the social functions with a network. And so some of the fabrication things, can I do a little bit more on this? I'm sorry. Okay, this is a stuffed animal design tool. So that it was very difficult for all the materials and the skins and created. But this is instantly creating the stuffed animal. You can design on the left window, and then the right window is patterns you should create. And then this is a 3-dimensional kind of design tool. So this is when the mother wants this one stuffed animal to their kids, she can instantly create by herself for loving kids, right? Okay, so this is very much personal. Okay, so the personal fabrication is one of the way of utilizing it, and then kind of learning from all the materials, and everything. So the question is, what about the liability? What about the intellectual property things? I mean, if you create and design is flying on the internet, and then you create the things, and what if that injured somebody? Okay, so that's the product liability thing. So what we are doing for this purpose is Okay, what we are doing is put the RFID. See, the left one is the RFID, and drop it, and then into the materials like that, so that it's numbered and uniquely identified through the RFID in it. So you can check what it's made from, and you can measure, and then this is a register. Therefore, this is a kind of futuristic idea about what we are proposing, that even if a personal product, then it's going to be registered and it's going to be checked, and for safetyness and other things with the community and local people and all over the world. So this is a kind of combination of the digital fabrication and the internet. and the social network.
Well, thank you very much, Murai-san. Well, I think it's very interesting to see this 3D printer social network distributed manufacturing. Also, we saw Kawada-san's next stage robot that actually impacting changing the way we do manufacturing in the conventional factory. So it seems like right now we have a quite substantial change in the paradigm in the manufacturing. What is the take on this? Murai-san, do you think we're going to have a further stretch and going to change a quite substantial ecosystem on the manufacturing industry?
I think so. Not only the manufacturing industry, but also the delivery system. Because if the design is going, this design is digital things is going around, and then you can't check. There is no border, by the way, on the world. So it's not the import-export concept at all, right?
Yeah.
And then the delivering job at all, because it's kind of utilizing the local materials and then producing the local things. So a lot of different things. But more importantly, what I want you to understand is that the personal creativity in a very inexpensive and the commodity way can produce things. Okay, so that's a really important part.
Yeah, very interesting. So Kawada-san, actually, your robot is now in a rather conventional factory. But do you actually see you envision like this 3D printer, more social manufacturing, combined with, for example, next stage robot, because they can actually program for each manufacturing process. Then we actually have the components printed on spot. Any robot actually download a bigger picture and assemble those components. Right. So, do you think you envision a much bigger future on this?
My robot is not very smart, and we are not a powerhouse like other robot companies. So we would like to work with other people, companies, smart people to do things together. And what Kitano-san, what you said is, I think it'll happen. The best nice thing about the human-shaped robot is it can use human tools, and it's very intuitive for what will this robot do. It's a human-shaped. It's very predictable.
Yep.
And but with the what Dr. Murai said was very eye-opening for me with the RFID. So new type of manufacturing. I thought mine was cutting edge, but I think there's much more out there, and we have to collaborate to make that happen.
Yeah. So Benjamin, I think you look at the Silicon Valley and Shenzhen, and then also you're frequent visitor to Japan. So this is interesting because we saw a little bit hardware startup, but I think the hardware startup is probably different from the conventional hardware that people are talking about. What do you see as a new type of hardware startup? What is the characteristics compared with the conventional so-called Japanese monozukuri kind of company?
Yeah, I think the current change with hardware startups is that the hardware is getting increasingly commoditized.
Yeah.
So Xiaomi is a great example of that. They released an activity tracker for $15. They do smartphones just as good as the best Android smartphones on the market for less than half the price, with disruptive distribution, very high quality, almost no inventory because they sell direct. So I think if you want a chance as a hardware startup or hardware company to survive in a market where things get commoditized, you need to do something that's actually hard to do. And typically, all the startups we invest in are startups for which the hardware is just the entry point. And the key is really into the science that goes behind what they're doing. So it could be medical science, could be material science, could be physics, like new sensor technology that's proprietary to them. Or it's, of course, on the software side. So it could be algorithms, in particular for computer vision, for robotics. It's really important. And in some cases, like original algorithms or artificial intelligence. So I think that's really where it's going. When you see that the prices of an activity tracker, smartwatch, or drone is dropping, even like a consumer-type 3D printer, today, you can find models for just a few $100s. Like, it's absolutely dropping in price, and the margins are going to be nowhere. There's very little defensibility. So you have to do something that's really hard, providing a service for which there's added value. I think that's one of the key challenges.
I think beyond top that, I think there's a kind of conventional belief for the Japanese industry, like hardware building. This is Japanese good at. But like, we couldn't get the Google or the Amazon because we're not good more on IT or information side. But if we think it's back in hardware, when the probably Japanese still have an edge, do you think it's still that the case the game have changed dramatically, or game going to change very rapidly? So like, those advantage with what generally people industry in Japan believe is no longer the case.
So I'll be very quick on that. But if you do pure hardware, I think it's really hard. It's become really dangerous, actually, because reverse engineering is now extremely efficient in China and elsewhere, but in China in particular. So if people can just take your product, open it up, look at it, and redo it, and then sell it for half the price, then it's gonna happen. In some cases, they actually reinvent it. Maybe so you're probably all familiar with Segway. Maybe you've seen the more modern kind of version where it's kind of like two wheels on the side, but there's no like thing to hang on. You just stand on it, and you tilt your feet to rotate that. So that's a fairly new invention, and the inventors actually the product that they have developed is not very good in terms of reliability and design for manufacturing. So it's not really ready for mass production. In China, just right the corner, you can find very similar products with much better engineering. And they didn't copy from anywhere because there was nowhere to copy from. They just looked at the concept like, okay, that's good, we can do that. And they just did it. And they do it better. So you have no choice. Like if you don't want to be commoditized really fast, either you go with very high value components, very high tech. That's what Japan is good at. And you have some defensibility because it's really hard to do. Or you have to bring in some form of defensibility in the form of science and software.
Thank you very much. That's very insightful. So like on one side, like we have to have like a very sophisticated components no one can copy easily. On the other side, we have to actually work with like a more information, big data, or science behind it. So Murai-san, I think you are involved in a lot of Japanese policy decision making or committee, so to speak. But try to get like combine the big data, how to use that IoT, and probably we're now seriously think about it, combine them together, the monozukuri or hardware industry. What's your take on this?
Okay. One thing about the IoT things. I mean, IoT is seems to be a buzzword especially for the Japanese. The government initiative and for the future information technology area. And we've been discussing about a lot about what is the different from IT to IoT, right? I mean, when we've been talking about IT, then please use a computer and the internet for your businesses, right? That has been done. And what's the difference for the IoT? IoT is the data, right? So utilizing the data. So can you utilize the data for your innovative, the operation of the company and the businesses. So the question, getting back to the government policy things, then probably the Japanese government from this year for the 5 years, what's going to be emphasizing on for the regulation things that utilize the safe utilization of the data for any of the segment of the industries. That's one of the policy. Yeah. So even for hopefully the health, not M, but the health data at least. Yeah. Okay. Hopefully closer to the hospital, reaching to M. Yeah. Data.
You have a problem of saying anything.
It's very difficult. Medical data. I'm sorry. Medical data is very difficult.
I know.
Anyway, so the utilization of agriculture with the data, and what's going to be the innovation on that? So data. And the data generated from things, and then the data has to be analyzed, which is artificial intelligence things, and the deep learning and other things. So this is a big game change.
Okay, so now let's switch gear to the player side. Okay, we talk a lot about kind of technology. Okay, so for those cutting edge, fast moving technology, we actually look into the startups. I mean, big company might sometimes succeed, and more likely the startup are gonna be the major player. So We have an issue in the Japanese like a startup, ecology, and then we are struggling. And Benjamin, I think you have like operation in Silicon Valley and Shenzhen. And then, from my perspective, if you have like Silicon Valley, Shenzhen, that's enough. Why you are interested in Japan? I think obviously you're visiting Japan, trying to find a company to invest. Like, what's attraction in Japan, so we can still take advantage of your interest?
Yeah, so we're based in Silicon Valley. Not because we want to move every job to Shenzhen or to China, but because it's a resource, just like Silicon Valley is a resource. And as a startup, your job is to find the best resources. So we encourage companies to actually keep the R&D wherever they're from, where they can probably find really good engineers and talented people, probably cheaper than Silicon Valley, and probably easier to manage than in China. But if you're making things and you want to get to scale at some point, China is definitely part of the equation today in the world. Even if you have really high quality, like high-tech components in Japan that you want to use, that's going to be assembled, that's going to need plastic injection, that's going to need metal parts, that's going to be, you're going to need the entire supply chain. So now in terms of where the innovation comes from, I think innovation doesn't really have borders. Of course, some places have better environments to support innovation. If you can't even make a prototype fast and cheap in where you live, because you don't have this infrastructure or you don't have any access to capital, it's really difficult. Like in India, there's lots of really good engineers, but when I talk to entrepreneurs from there, they say it's really, really hard to get even a circuit board printed at a good price so that they can iterate on prototypes. So I think Japan has a lot of attraction in terms of engineering, in terms of product design. This is not new to you. You're familiar with that. But I think what's missing is a bit, let's say, a vision that goes beyond a niche product. Yeah. So trying to do something that's larger, maybe more ambitious and more global. And to be more global today, you need to integrate as part of your experience or as part of your team, the understanding of the ecosystems you need. So China, probably US, if you're targeting, like, when you say go global, it means go US, right? Generally, as a start. So if you've never been there, if you've never spent time living there, not just visiting, the Google campus and have free food, which happens a lot, but you need to have spent time there to really get to understand, or you need to have people on your team who have spent time there as part of the founding team or the executive team. So I think the idea is really combining this global awareness and experience so that you can reach global markets. And I expect Japan to get there.
Yeah. Thank you very much. Do you have anything to add on this?
Yeah, actually, I really agree that kind of diversity of cultures about the kind of creating things and the innovation, especially when the hardware being a commodity and that personalized, and then you can create a new type of a hardware thing, and then this is very exciting in Shenzhen, and then also a lot. Very different in India, for example. Yeah. So that's a mixture of everything. By the way, then I'm working with the Indian Institute, IIT.
IIT, yeah.
In India, Hyderabad, and then I found the very interesting things. We worked on the digital fabricator things, and they are talking about the bicycle. Their bicycle is when something broken, then they're gonna produce by the 3D printer for that broken part, okay? Replacing it, and then so now the bicycle's life is going to be eternal. Yeah. I mean, it didn't die. It will never die. It's forever. The bicycle lives forever because part by part, they started to replace when when one part is broken, right? Okay, so it's a forever bike. Okay, so that was changing the definition of a thing already. So this is probably this idea only happens from the Indian culture, right? Culture in India. Okay, so that was very very much we can learn we can enjoy those diversity of creativity around the world. and then learning from everybody.
But, interesting one note is like I was involved in Sony's Aibo project with Robot Dog. Sony unfortunately decided to discontinue. Now we discontinue the service. We don't have any components to replace. And then there's a group of people, ex-Sony engineer actually fixing it. But if we can actually manufacture the component by 3D printer, we can actually fix that robot and we keep it going forever. Well, we can actually manufacture the tissues and we can actually place and we can live forever if we want, maybe. But actually, I think it's a time to open the question, for the floor. Like, okay, so you're the first. Yeah.
Thank you very much. Ime-jin LaPlante. I'm a consultant in data science, and I'm here on behalf of the American Chamber of Commerce in Japan. Thanks for sharing these very exciting innovations. My question is about teaching people to interact with these technologies. So, for example, Kawada-san, when you bring your collaborative robots into the factory, what kind of a reaction or interaction are you seeing, and how do you manage that? Thank you.
Unfortunately, I only know about my robot, so my world is very small. But like I said earlier, the human-shaped is very important thing, and the robots at the Glory Factory, each robot has a name, so they address each robot with a different name, and the people that work there, today's Mr. Euro, because they make money, right? Money checking machines. So Euro robot is not feeling so well, so maybe we'll change it with yen. So interaction, to surprisingly in Japan, is very positive, and I watch Hollywood movies, and they all at the end revolt against human beings. But in Japan, so far, has been very good. I think it's also because we don't have enough people to work, and that's going to get worse and worse. So people see robots as a necessity to keep going. Does that answer your question?
There is a lot of research activities going on about the robot-human interaction things, and probably Matsuo-san, you are part of it, right? And it's a human-robot interaction community, and then there is one called Roman, which is just happening last week in somewhere in Japan, and then yes, that's a very big, important issue. That what's going to be the future issue, and that there is a tremendous amount of the work on the recognition, the humans, education areas, and those are the very, very strong researchers working on to explore that kind of area.
Hi, my name is Jose Fernandez. I'm a student here at Globis. I'm a medical doctor. So my question is about, why do you think that companies are focusing mostly on healthcare and fitness rather than diagnostic and therapy? We have not seen any major breakthrough in diagnostic and therapy. Why?
So just wait for startups to come out because I think it's just easier to do, so I'll take that question. So it's just easier to do general fitness because you just need like a 9-axis accelerometer on Bluetooth on a battery, and that's all you need. And you connect that to your smartphone. So it's just really simple. But it's not really delivering like medical value. It's like general. Also, it's easier to go to market because you don't need to go through FDA certification. If you want to get a medical device to market with actual certification, as you probably know, it takes years. It can take 1, 2, 3 years, depending. Like we have one of the startups we invested in currently in the program. They do implants to help with the recovery of spine surgery. Well, that's going to take a while to get to market. So in some cases, I think it's just a matter of like available technology that was made kind of commoditized, thanks to those guys, actually smartphones, made accelerometers really cheap on the Bluetooth components really cheap. So now you can make affordable devices. And for consumers, that's great. On the medical side, if you do something more complicated, it's going to be more expensive. And then the question arises, who pays for it? And just to give some hints on what I think might be the future for like medical diagnostic and maybe beyond that, is that essentially the advertising paid for the internet. The reason we have free search, free email is because advertising pays for it. So that's more or less the main business model of the internet. What's the business model for IoT, for medical devices? At the moment, it's kind of questionable. And if you have to shoulder all the costs as a consumer, it can be really expensive. So I think the future of that is actually insurance is going to pay for it. But for insurance, not only, so first you need to device it to be certified, then you need to device to prove that it's delivering some value, and then you need the insurances to actually embrace it, because then the business of not paying back the money they get, right? They want you to be healthy so that they keep the money you give them. So I think that's going to come, but it's just a bit of a lag to get there.
Yeah, well, I think in my experience is that there are companies actually who have the technology that can be either medical device or non-medical device. And many of them actually choose to be non-medical device because like they have to go through all the FDA approval and all that. And if you actually do like a non-medical, even if product doesn't work out, you might actually pivot or you might sell off. You know, you can actually recoup some part of investment, not entirely. But if you actually try for the die-hard medical device and you fail to be approved, you get zero return on it, and that's really tough decision to make. So that's, but of course, like if you have like a big companies like major pharma or major diagnosis company backing you up, yeah, you should just go for that. Actually, that's very important thing to do. Is that decision is not because it's socially important or not. It's more or less an investment returns or the risk of the business. I think that's okay. Any other questions on the back?
Okay. My name is Daniel Chimize. I am from Globis MBA program. I want to ask for the startup. My question goes to Mr. Benjamin. When you have great ideas or people who have engineering background and decide to possibly partner with you, do you also finance them in area of trying to spread the product across to ensure that they have dividend for their own effort and ideas?
Yeah, that's a really good question. So yes, so we finance the companies. Typically, we invest $100,000 in each startup with follow-on of at least $200,000, so that's $300,000. And what we found is that if you have a great idea and a great prototype, we can initially help you get to a product stage and you can start selling. We can even help you launch your product with crowdfunding because we have a lot of experience with that. But then, to be a sustainable company in the long term, you need to establish like repeat sales. And that's the next thing we're tackling. So we're starting a new program in San Francisco that's actually focused on that, helping startups that have products to get better marketing, better distribution, better sales. So, yeah.
Any question? Okay. You're second.
I am Kaoru Hatano from student of Globis. And my question is, Mr. Benjamin said that the startup of hardware need something science. So when we like to start up such a hardware company, what we can do when we don't have engineering knowledge and. Yeah.
Well, tough question.
Thank you.
I think that was the topic of a Dilbert cartoon this week. There was you may be familiar with Dilbert, like the management-related cartoon. There's the manager guy with the pointy hair, and he goes to one of his engineers and he says, "Well, I have an idea for a startup, and but I don't have technical skills, and I just need engineers and investors to get started." And then I think his engineers look back and okay, so basically you have nothing. So it's, yeah, so what you can do, however, is that you actually don't have nothing if you don't have technical skills. What you can have is done research enough on the market so you can talk to companies who could be the customers of what you want to build and make sure the market exists. Because the biggest waste of your time on energy, on resources, could be to build something nobody wants. So actually, if you tell me, look, I can't build that thing, but I know what kind of engineers I need, and I've talked to like 50 people in that particular industry, and out of the 50, 20 of them wanted to buy the thing of the spot, and I know I can reach the price point to be profitable. So now I just need the resources to make it happen. It's actually really, really important research. And that can validate a business even before you spend almost any money on it and you hire anyone. And I think actually the problem we have with our startups is that because they engineer, they love building. So they start by building, and they haven't quite validated if there's a market. Like, for example, the fabric printer is an amazing invention. It's like, you know, the Macintosh of moment for the fabric industry and the fashion industry. They don't have yet a very clear customer because the technology is not there yet. So yes, you can do something.
Any other questions? But yes, on the way back.
Analyze why you think. Sorry. Could you analyze why you think you have one startup in Japan?
Only one.
Sorry, I'm hogging the questions, but those guys have the answers. Here's one. So what I understood from, so I was at 2 other conferences this week, and I met probably with about 200 startups in one of them. And there were, first, there's very, very few hardware startups in general out across all the startups, maybe 10% or maybe more like 5%. And I think the challenge is that in the software world, it's much easier to start, and people have a lot of education around how you can build startups now, and there's a support system. But people who do hardware, they're typically electrical engineers, mechanical engineers, product designers. They're much less exposed to that environment. And I think a lot of interesting research is actually happening with people like the panelists here, and also within large companies. And they could be spin-off from universities. They could be spin-off from companies where they decide, okay, this is an interesting product, but we need to make it separate so that they have autonomy. So let's spin it off. And that could happen, but maybe there's less of a habit to it. There's less bridges between research and entrepreneurship. And that's something that possibly can be bridged, so like with encounters like these.
Okay, you know, like my university, a lot of startups in the past, now they're doing the startups of the hardware. The reason is that, you know, as Benjamin said, hardware becoming a commodity things, and therefore then it's easier to design, and then creating the things, and also inexpensive. Therefore, it's very easy for them that their idea and mind is going to be applying to the actual application areas and the services with the hardware. So I just gave 2 of my students a startup name cards to Benjamin today.
We'll be in touch.
Okay, I think it's so. Okay.
I'm from Osaka, which I believe that is one of the famous manufacturing capabilities in Japan. But I'm questioning about why the startups is passing over Japan rather than rushing into Japan. So what caused you to go to?
So we had that conversation. I was asking, do you invest in startups? I told him, look, Mr. Kawada, we have about a dozen robotic startups doing very interesting things. Are you guys interested in that? And I think, what was your answer?
We want to do it internally.
It wants to do internally. So that means that for some companies, for some startups, they just can't find customers. So that's one challenge, of course. Of course, if you do consumer devices, it could be a very good market. Like Japan is a very large and rich market. But for many foreign founders, they're much more comfortable speaking English than Japanese, even if they're not American. So for them, it's an easier access to US. Also, I think Japanese consumers tend to be very demanding in terms of they expect over quality, essentially. So as a startup, it's really difficult to do. You're not Apple. You need to get something to market that's good enough. And actually, customers in the US, they're quite happy with good enough. So that's probably another reason.
Well, I think that there are some change in atmosphere. The behavior in the Japanese company. For example, Sony actually I'm running their program to actually have a startup, and initial batch actually that was all Sony engineer, but now actually collaborate with the external entrepreneur. So we contract with the external entrepreneur, and then match up with the Sony engineers, depends on the capability, and then try to actually create a joint venture with the so like Sony. We have nothing to lose anymore, so we can do quite a bit of radical things, So like we can do that, but I think that depends. I think things are changing right now. I think. Who else? You have a question? Yeah.
So actually on that point, so I actually started a company in Japan, a venture company, but we were focused on industrial sector. I think the challenges for industrial sector is quite similar to hardware, where in Japan there's a very low tolerance for risk. And also, as you mentioned, a lot of the big companies in Japan try to do everything they can in-house or in partnership with a university. So if you're not with a university or in-house, the chances of follow-on funding is very, very low. So I actually found in Japan, we met with a lot of the big companies, like, yes, we love what you're doing, we need this right now. But the risk factor, we just can't do it. Unless it's internal, the risk factor will not happen. The only interest we got was some foreign investors looking to invest into Japan because they saw the technology was right. So I think that's links with the previous discussion we had in this room about risk. And one of the things that's holding us back a bit in Japan is trying to take on more risk to get the big wins that you guys are seeing now.
Yeah, I have a comment about that. When the iRobot's Roomba came out, I thought it was a shame that it was not a Japanese company. I thought it was fantastic. So I talked to some of the big electronics company engineers about it. So, no, we were working on it 5 years ago. We had it all done, and we have it all ready to go. They presented it to the management, and they said, the legal guy says, okay, what if it hurts a baby, or if it topples over a Katori Senko and burns a house, and then the product gets shut down like that. And you're right, that is a problem with the Japanese companies. I mean, for instance, my company, nobody knows Kawara Industries is a robot maker, but nobody came up with such a robot, right? I mean, we did not know there was not a market like that. Fanuc or Motoman, they did not come up with it. Now they're coming up behind us and may overtake us very soon. But that is true. I mean, we need more guinea pigs, and that is a fantastic thing about Silicon Valley. And I hope a place like Globiz will get more people from Japan doing more risk taking.
Yeah, just to comment on what you just said, I think in a way it's a mirror of what you said. Like we have nothing to lose, so we can take risks. And on the other side, if things are kind of stable but not growing fast, you feel very risk averse. So there's really two situations. Either everything's growing and you're very optimistic and you take risk because the downside is not much, or you're really in trouble and then you take risk because you have no choice. And the problem is that Japan is at this kind of stable, yet not so amazing, yet not so bad, that doesn't push for risk. So there's kind of economic reasons for that. And another reason is probably related to more like, let's say, the culture. And I don't think it's unique to Japan. I'm from France originally, and I don't think France is particularly risk-taking. But I think the US, in the way it was built and in the way Silicon Valley was built, is very can-do, action-oriented, and then they do first, and then they count the bodies. And if things go well, then it will benefit enough, and you can recombine those who fail. So it has worked pretty well, like over the past 40 years for the US, or maybe even beyond that. So there's really, I think there's partly cultural and economic reasons, and it's kind of difficult to reverse engineer or to re-engineer.
Yeah, also, probably the one of the approaches, like what we just started in the government for the big data use is also the Japanese company is not using the data because of the risk, and so there should be some mechanism to prepare the environment for doing taking some kind of easing some of the risks from the industries and like ADL, ODL, and that kind of a mechanism built in and supported partially by the government to create. We probably lack of a number of attorneys, right?
Yeah, maybe. Yeah. Well, thank you very much. I think we have to close the session. I think final message, final comments from all the panelists. 30 seconds. Final comments for some of the potential entrepreneur for them to encourage them to challenge. Starting from
Okay. As I mentioned, then the use of the data on the internet is changing a lot. I mean, used to be the big data was on the text based from the web and the SNS and everything. Now it's a more broader data generated from the sensors and the devices, camera, and etc. Therefore, the artificial intelligence and the other things, it's a very, very big change on the game about the digital space. Therefore, you think, please, about the new approach is going to be necessary. This is a very exciting time.
Okay, Kawada-san.
Benjamin, just if you have any good companies I can collaborate with or buy, let me know, all right?
Yeah, thank you very much. Appreciate it.
Thank you so much.
That's a good one. I hope
To comment on that, I hope you don't buy them too early, because otherwise it's not good enough for us. But I appreciate that, and I really encourage you also to visit us in Shenzhen to see what's up.
Oh, I love China. I love
So the deal is done. Thank you very much.
Sorry, I had like one phrase of sorry, just to wrap up. I think one of the challenges in Japan is around risk-taking culture, and I think we're all aware of that. And one way I would see to maybe act on that is to create some kind of a hero or role model. And I think maybe the best way to go about it is actually to create a fictitious one through manga or TV drama. And I would love that hero to be a female tech entrepreneur that does some kind of hardware involving China, involving US, involving Japanese design and engineering as a story that people could be inspired by. So.
Thank you very much. I think it's very interesting. We have interesting change in circumstance and opportunities and new technology emerging, and with venture capital Benjamin actually is still interested in Japan, and we have proximity to Shenzhen if we want to have a mass production. So we want to take advantage of that. And as Benjamin pointed out, interesting because I said Sony has nothing to lose, so we can take a risk. If you think about Japan, Japan's future, I mean, decreasing demographies and growing China, and we have not much to lose, so we can take a risk now. Well, thank you very much, and then thank you very much for attending this session. Thank you very much.